Okay guys, first before you guys take your quiz today, I want to go through the things that we discussed last week with those dosage calculations. Your all's dosage calculations quiz this morning is going to look very similar to that homework assignment that I emailed to you guys last week. So kind of a collection of different things involving dosage calculations. So remember we started last week with just going over kind of just basic dosage calculations that said, if we have an ordered dose of, say, 75 milligrams of medication, and we look on the label to see what we have, and that medication comes in, let's say, 25 milligram tablets. Then based on this information, I just want to know what we're going to give this person. So if the doctor orders 75 milligrams, but each tablet contains 25 milligrams of medication, then they need 3 tablets. They need 3 times that dose. So the answer here would be 3. We're going to give 3 tablets. So what we did last week is we also introduced the formula that we can follow for all dosage calculations that looks like this. D divided by H times Q. Keep in mind, D stands for the dosage that's been ordered, so that's going to be our 75 milligrams. That's going to be our dosage ordered. H stands for the dosage that we have, so the dose on hand, if you want to look at it that way, that's our 25 milligrams. That's going to go right there. And our Q is the quantity that we have on hand, so meaning the quantity and the amount that each dose contains, or that a dose is. So there's 25 milligrams in a dose, but a dose is 1 tablet. So let me actually put that in a different color. So the per tablet, that's per 1 tablet. So in our case here, the quantity was 1. So entering that into the dosage formula, and some of these, again, if you can do them in your head, do them in your head. We did 75 milligrams divided by 25 milligrams times 1 tablet. That's how we set up that dosage formula. Again, the stipulation for this, the rule for our dosage calculations, our dose that we have ordered and the dose on hand must be the same unit, because we want those 2 units to cancel out, so that we're left with the only 1 unit left in the problem is the unit of the quantity, and that's why the unit of our answer is the same. That answer comes in tablets, we're going to give tablets. So make sure of that as we go through different calculations, that the quantity is the D and H are the same unit. So let's take a look then at another. So if, say, we have an ordered dose of, say, 10 milligrams, and we have a medication that comes 20 milligrams per, let's say, 2 milliliters, per 2 milliliters. So again, what this means, based on this medication here, that for every 2 milliliters that a patient takes, they're going to receive 20 milligrams of that pure drug. Our patient doesn't need 20 milligrams. Our patient only needs half that. They only need 10. So therefore, they're only going to take half of this quantity. They're only going to take half of this dose. So if you're doing that in your head, you may be thinking, okay, well, they're only going to take 1 milliliter then. That's correct. That's because what we could do if we set that up into our dosage formula, D is our 10 milligrams, H is 20 milligrams, and Q in this case is 2 milliliters. So yes, D and H are the same unit. We're good to go here. We take 10 divided by 20, which is 0.5, and then 0.5 times 2 gives us 1. So they would only take 1 milliliter. So another way that we can utilize that dosage formula there. If, let's say, a couple things that we discussed last week too, as I mentioned just now, make sure D and H are the same unit. So if we ever have, an ordered dose of, let's say, doctor has ordered 0.5 grams for a medication that comes in, I don't know, let's say 100 milligrams per 2 milliliters. So here, if we were to set this up into our dosage formula now, we would realize that D and H are not the same unit. We, have ordered 0.5 grams. We have 100 milligrams, and our quantity is 2 milliliters. So looking at this, D and H, yes, D is in grams, H is in milligrams. So what we talked about last week was just converting one to the other, meaning that you can convert the doctor's order of grams into milligrams, and then they'd both be in milligrams. Or you could do the reverse, and you could convert the H, the half of 100 milligrams, into grams, and then they'd both be in grams. Either way, you'd get the right answer. We just need them to be the same, just by converting one to the other. But last week I did mention that the most common unit that you guys are going to see is milligrams. So my advice to you guys in situations like this was to get everything into milligrams. So what that means is I am going to change that doctor's order from grams into milligrams so that they both will match the milligram dosages there. And we're not changing the doctor's order. The grams, what we're about to do is convert them to what they're equivalent to in milligrams. So it's just an equal equivalent. We're just making sure it matches the medication that we're working with. So how we did that last week, we talked about those metrics, and so hopefully you guys got the video as a reminder on the metric conversions. There were two ways that we could do that. One, we could remember this chart. We've got this chart, kilo, hecto, deca, base, deci, centi, milli. I'm just using the letters here, XX, and micro, to remember our decimal movements. That if I'm converting from gram to milligram, then all I need to do is look and find where that is on our map here. Gram is one of our bases. Milligram is what we're converting to. I circled the right one. Milligram, we're trying to convert to milli, which is there, that first M. So what we do is we count the movements. To get from base to milli, we're moving to the right. So I'm just going to point to the right. And we're moving 3 places. Base to deci to centi to milli would be 3 movements. So 3 places to the right is what we're going to do with our decimal. So with 0.5, we take that decimal, move it 3 places to the right. That's going to convert this to 500 milligrams. The other method that we talked about for these metrics, if you're not using that method, we discussed the stair-step method, which was a little bit easier because in terms of memorization, that you only had 4 things you had to remember. You had to just remember the 4 most common units that we dealt with in metrics: kilo, and then our base, milli, and then micro. So it's still the same units that are up on this chart. It's just kilo is here, base is here, milli is here, and micro is here. Those are the 4 most common units, and you'll notice that those 4 are actually each 3 apart. So 3 apart means that if you remember when we discussed this last week, that all of these prefixes, all of these metric units are all based on units of 10. So 3 tens would actually be 1,000. So the stair-step method just says this, that an easier way to remember, to maybe think about this, is anytime you have to go down a step, you multiply by 1,000, whereas anytime you go up a step, you simply just divide by 1,000. So in our conversion that we're doing in this particular problem, to go from gram to milli, that's again base to milli, that would just be down 1 step, base to milli. So therefore I would just take my 0.5 and multiply that by 1,000, and 0.5 times 1,000 is 500. So still getting 500 no matter which metric conversion method you're using. It's just making sure we're converting those grams into milligrams. So pretty much for today's, if metrics is something that's kind of giving us a hard time, just remember that, the only thing we'll probably have to do on today's quiz is to convert those grams into milligrams. So all you really have to remember is moving your decimal 3 places to the right or times 1,000, because that's the only conversion we're going to really do today. with the metrics because we just want to make sure that our units match with our dosages. So that's our metric conversions there. So gram, just remember that, gram to milligram times 1,000. So what we have here then, oops, I erased my conversion. Our conversion from 0.5 grams, remember we just converted that to 500 milligrams. Like I said before, we're not changing the doctor's order. We're simply saying, hey, doc, your order of 0.5 grams is the exact same thing as 500 milligrams, and since our medication comes in milligrams, we want to look at it that way. So that's what we're going to do. We're going to look at the 500. Now that they're both the same, now we divide this out. So we would take 500 divided by 100, which is 5. Take that and multiply by 2, because that's our quantity there. So 5 times 2, this person would need to take 10 milliliters. So keep that in mind too as you go through today's quiz, that if our units don't match, we need to get them into the same unit. So just convert one to the other, and like I said, more than likely it's just going to be grams to milligrams, making sure that they're in milligrams then. Another thing we discussed last week is to keep in mind abbreviations, those medical abbreviations. When you see those in dosage calculations, you want to pay attention to them, because then you may be asked what a patient would need to take in a day and what, based on what they would take in an individual dose. So what I mean by that is, let's say we've ordered, a patient to take, say 50 milligrams to take PO, which we know is by mouth, to take, let's just start with TID. So TID, you guys know, means 3 times a day. And we have a medication that comes 25 milligrams per tablet. So starting with just kind of an easier one here. So if they need 50 milligrams and they come in 25 milligram tablets, we know that that's double that amount. So you guys hopefully are doing that in your head, and you know that that means they would have to take 2 tablets. So we would give 2 tablets. If you didn't, again, remember the dosage formula. D in this case is 50 milligrams, H is 25 milligrams, and our Q is 1 tablet. Remember, all tablet medications, it doesn't say 1 right there, but it's always assumed to be 1. Any tablet or capsule medication, the quantity is going to be 1. So 50 divided by 25 times 1, we get 2 tablets. So that's what they're going to take in a single dose. But based on what we have here, it says that they need to take not just 50 milligrams, they need to take that 3 times a day. So second part to these questions, and you'll see this on today's quiz, and you saw it on last week's homework. If I asked you what they take daily, then that's going to be incorporating this abbreviation. They're taking that 3 times a day, so we've just calculated what they took in a single dose, just taking that 50 milligrams, that was equating to 2 tablets. They're taking that 3 times a day, so if they're taking 2 tablets 3 times a day, all we have to do is take 2 times 3 to see that they're going to end up taking 6 tablets in a full day. So that's all you do when you're asked for a daily. I just want you to take what you got as your answer in your individual dose, and then you're going to have to multiply it by something based on whatever the abbreviation is. You may have, keep in mind if, not just TID or BID, which, is 2 times a day, or 3 times a day, then 2 times a day, or QID, which is 4 times a day. But be on the lookout for, say, like every 8 hours. If it says every 8 hours, then, not as straightforward as just, oh, they're taking that 3 times a day. But every 8 hours also means 3 times a day. And that is because, if you remember, let me get some room down here. Because we know that there are 24 hours in a day. So based on a 24-hour day, if they're taking that every 8 hours, then what we would do is just divide that to see that that's going to end up being 3 different times in a day. So every 8 hours is the same thing as 3 times a day. So if this was the equation again, 50 milligrams, 25 milligram tablets, yes, the dose that they would take is 2 tablets, but they were taking that every 8 hours, so therefore they're going to take 6 tablets in a day, because once again we would take 2 times 3. If it was every, let's say, every 4 hours, then again, just like we did down here, we would take that and we would divide that by 4 hours. So therefore, they're going to end up taking that. Let me erase this big 3 here. 24 divided by 4 is 6. So therefore, they're going to end up taking that 6 times in a day. If it was every 4 hours. This is just a what-if scenario here. So then our answer of 2 tablets, we would end up taking that and multiplying that by 6, because they're going to take that dose 6 times in a day. So they're going to end up taking 2 times 6, which is 12 tablets in a full day. So just some things to keep in mind as you see those medical abbreviations. Be on the lookout for those, as I may ask what they would take in a daily dose then. Let's see. Another thing we talked about last week was when looking at parenteral dosages, meaning parenteral means injections. So injections, whether it's injected into the skin or into the vein. Sometimes injections come in vials that are really small, and so labeling them may look a little bit different. Sometimes they look the same as far as, it may say, 25 milligrams per 5 milliliters. So meaning for every 5 milliliters of that injection, they get 25 milligrams of drug. So it still looks the same. But every once in a while you may see something like this, where if let's say the ordered dose is 5 milligrams, and we look on that label for that vial, and the vial says that it is a 1 to 1,000 solution. A 1 to 1,000 solution. With those ratios, anytime you ever see a ratio like this in these dosages, we have to just kind of know the definition for these, what ratios represent. Ratios always represent a grams to milliliters relationship there, that it's showing in this particular medication there is 1 gram per 1,000 milliliters. No matter what the ratio is, if it's 2 to 500, then that would mean there's 2 grams for every 500 milliliters. If it's a 6 to 7, I don't think you'd ever see that, but it'd be 6 grams to every 7 milliliters. So that's the relationship here. So just have to remember that it's always grams to milliliters. So anytime you see a ratio, when you go to plug that into your dosage formula, so your ordered dose is just given to us as 5 milligrams. Our H, remember, is then 1 gram. So that's important to remember that that's in grams, and your quantity is that 1,000 milliliters. So just like we talked about before, we need to make sure D and H are the same unit, and if they're not, we have to do some converting. So as usual, I'm just in the habit of getting everything into milligrams, so I am going to convert that bottom unit down there from grams into milligrams. And once again, remember, gram to milligram is just either times 1,000, because you're going down 1 step on your stairs, or moving your decimal 3 places to the right. So that would end up taking 1 and making that 1,000 milligrams. So to complete this problem, we would just take 5 divided by 1,000 times 1,000, and that gives us an answer of 5 milliliters. Don't forget, your unit of your answer is the unit of your quantity. So I think a lot of times people answer that in milligrams because they remember that's what was ordered, but the answer we're looking for is what to give in that injection, that 5 milliliters. Remember, the milligrams had canceled out within the problem here. So if you just remember that, if you see ratios, just remember that ratios mean grams to milliliters. So you may have to do some converting in those problems. Very similarly, if we have an ordered dose of, say, the same thing again, 5 milligrams, and that medication comes in a percentage. So say we have a 10% solution. What that means, actually very, that's where I kept saying the word similarly, similar to those ratios, percents can actually be looked at as ratios, and then they're one and the same. Anytime you see a percent, keep in mind that percents are always out of 100. No matter what you're talking about in terms of the percentage. If you got a 10% on a test, it means you got 10 out of 100 possible points. If something in a store is 10% off, then it's 10% off of the 100% full price. So what we can look at here, if I have a 10% solution, that means it's the exact same thing as the ratio 10 to 100. So go back to what we know about ratios. All ratios mean gram to milliliter relationship. So in this particular problem, that means I'm going to plug in my ordered dose. So there's D. H in this case is going to be 10 grams. And then we're multiplying by our quantity of 100 milliliters. So in your percentages, your quantity is always going to be 100 milliliters. So in this particular problem, we have to make sure again that D and H are the same unit. They're not here, so we're going to go ahead and do some converting. So I'm going to take that 10 gram and I'm going to convert that to milligrams. 3 places to the right, or times 1,000, would take this to 10,000 milligrams. So going ahead and dividing this, we're going to end up taking 5 divided by 10,000. Be careful with zeros, as sometimes we can leave out zeros or add extra zeros. So make sure you're watching your calculators as you guys are doing these conversions here. So we take 5 divided by 10,000, then we're multiplying it by 100, and that's going to give us 0.05 milliliters as our answer here. So they don't need a whole lot of medication from this vial, but that's what they would need. So look out for those ratios and those percentages, and just remember they both represent a grams to milliliter relationship. One of the last things that we discussed last week with our dosage calculations is be on the lookout for when a dosage calculation says to give something per kilogram or / kilogram, which means per kilogram. So meaning, like if I saw in an ordered dose, so this here, in these questions we're looking at dosages based upon body weight. If I have an ordered dose that says patient needs to take 10 milligrams per kilogram, then that means for every kilogram that any person weighs, they need to take 10 milligrams of drug. So for a person who weighed 2 kilograms, they would therefore have to take double that amount, so their ordered dose would be 20, because they would take 2 times 10. For a person who weighs 3 kilograms, they would have to take 3 times the amount, so they would take 30, and so on and so forth. So what's going to happen is, in these questions, we have to figure out what our patient weighs in kilograms, and then we're just going to multiply it by that ordered dose to see what our patient's specific ordered dose is going to be. We're also in these questions going to be given a have. We're going to be told how that medication comes, so we know how to plug in our H and our Q. So let's just say our have in this case is, say, 50 milligrams per 2 milliliters. And our patient, let's say our patient we have, their weight is, let's say, 37 pounds. Okay, so a couple things with this problem. Not only are we going to have to incorporate that patient's weight to figure out their specific ordered dose, or our D in our dosage calculations in our formula, but you notice that the weight is not given in kilograms. As you know, it says per kilogram, not per pound. So what I'm going to have to do is I'm going to have to convert that weight from pounds into kilograms. Last week I gave you guys the conversion for that. 1 kilogram is equivalent to 2.2 pounds. So in order to convert somebody's weight from pounds into kilograms, all we have to do is just divide by 2.2. So anytime you see a weight in pounds and you want to convert that to kilograms, we just divide by 2.2, and that will give us that weight in kilograms. So for a patient who is 37 pounds, we divide that by 2.2, they are 16.8 kilograms. So what that means is our patient needs 16.8 times this amount. Since it's 10 milligrams per each 1 kilogram, and they're 16.8, we just need to multiply that. So to figure out what our patient's specific order dose is, we just take 16.8 times 10, which is going to give us 168 milligrams. So I'm going to write this over here on the side here. 168 milligrams is our patient's order dose, and then we'll go ahead and plug in the H and the Q. So H is 50 milligrams, and our Q is 2 milliliters. So now completing this problem, I would just take 168 divided by 50, take that and multiply by 2. Looks like our patient needs 6.7 milliliters of medication. So that's all you have to do in those, is just remember anytime you see per kilogram, first, if you need to, figure out what their weight in kilograms would be by dividing that by 2.2. And then once you get their weight in kilograms, you just multiply that by that ordered dose to see what our specific patient needs. I did last week talk to you guys about what happens if the patient's weight is very specific, meaning that it's not just given in pounds, but maybe pounds and ounces. So let's take another one of those, but let's go, let's see a person like that. Let's say the ordered dose is, this time let's say it's 5 milligrams per kilogram. And we have a medication that comes, I don't know, let's say it's a very similar medication, comes 50 milligrams per 2 milliliters. So we'll say it's the same drug. But we have a patient whose weight is, like I said, kind of a little bit more specific, not just in pounds. So say we've got a patient who is 64 pounds and, I don't know, let's say 4 ounces. So now what has to happen, we have to incorporate the patient's weight, the full weight. So we're not just going to take 64 and divide it by 2.2 because that would leave out that 4 ounces. The reason why those ounces are there is because we need to incorporate every single ounce of their weight to make sure they get the exact amount of dosage, exact amount of medication for this particular drug, because whatever's going on and whatever the medication is that they're needing, they need to be very specific, very precise with these. So what we're going to do, last week we discussed, remember, how many ounces make up a full pound is 16 ounces. So if a person is 64 pounds, they are 64 pounds or 64 point something pounds with these ounces. What we're going to do is we're going to convert that 4 ounces into a decimal based on the fact that a full pound would be 16 ounces. So therefore they are 4 out of the 16 full ounces that make up a full pound. So kind of like, looking at this as a fraction, they're 64 and 4/16 pounds. But to make that a little bit easier, we'd rather deal with decimals to put that into our calculators when we're dividing by 2.2. So 4/16, what we're going to do is we're going to take 4 divided by 16. We just divide these two numbers, and that will turn that into a decimal for us. 4/16, some of you guys may be looking at that and see that that's a fourth of 16, and 1/4 as a decimal is 0.25. But a quick way to see that is if you take 4 divided by 16, it is going to give you 0.25. So therefore, this person is 64.25 pounds. So whenever you see ounces, just divide by 16, and that will give you that decimal that you're going to put after the number of pounds. So it's 64.25. Again, they're still in pounds. We've just looked at that as a decimal. But 64.25 pounds, we take that and divide by 2.2 to see what this person weighs in kilograms. And 64.25 divided by 2.2 is 29.2 kilograms. So they weigh 29.2 kilograms. So just like we did in the last problem, once we get that weight in kilograms, that means this person needs to take 29.2 times the ordered dose. So 29.2 times the 5 up here. So 29.2 times 5, they need to take 146 milligrams. So the ordered dose, I'm going to go ahead and plug that in here, 146 milligrams of medication. And then I'll go ahead and plug in our H and our Q that were given to us, 50 milligrams per 2 milliliters. So finishing this problem, we're going to take 146 divided by 50. I'm going to take that and multiply by 2. Our patients, or what they need to take, I'll have to write this down in the corner, I'm running out of room here, is 5.84 milliliters of that medication there. Okay, so I hope that jogs our memory on that. The last thing we talked about with that per kilogram when we're incorporating patients' weights is the safe dosages. So kind of similar to what we just looked at and how we take a patient's weight and multiply it by that ordered dose of milligram per kilogram. Here, it's not going to be in the ordered dose. Instead, in these questions, what's going to happen is we're going to be given an ordered dose. Let's say ordered dose is 50 milligrams to take by mouth every 8 hours. Sometimes this medication gives us what we have, but that have is actually going to be irrelevant in this question because we're only trying to see if this dose that the doctor has ordered is safe for our patient to take based on the label. So what's going to happen is on that label it's going to give us a safe range. It says on the label, it says a recommended safe range for anybody taking this drug is this. It may say, I don't know, let's say 10 to 20 milligrams per kilogram per day. Okay, so 10 to 20 milligrams per kilogram per day. And let's say we have a patient who weighs, let's say their weight is, let's say it's a baby, and they weigh, I don't know, let's say 11 pounds. 11 pounds. So first, let's figure out what our patient weighs in kilograms. Remember, all we need to do is take that weight and divide by 2.2. So taking that 11, dividing by 2.2, this patient is 5 kilograms. So they are 5 kilograms. So here's what we need to double check. So our patient has been ordered to take this, 50 milligrams by mouth 3 times a day, or every 8 hours, which is 3 times a day. So we know, just to kind of think about that in a full day, since our recommended safe range is also showing us per day, we need to think about what our patient has been ordered to take per day so that we can compare the two. So 50 milligram of that order dose up there, 50 milligrams, taking that 3 times a day, 50 times 3 would be 150 milligrams in a day. So that's what they've been ordered to take, is 150 milligrams in a day. Well, we need to double check to see if that is safe for our patient. So for our patient who weighs 5 kilograms, their safe range, according to this, says that for anybody taking this drug, it is safe to take 10 to 20 milligrams per kilogram. So there's the per kilogram here. So we have to incorporate our patient's weight into this number here, these two numbers. So what we do to see if it's safe for our patient is we're going to multiply our weight by both sides of that range to see what the minimum and the maximum dose for our patient is going to be. So 5 times 10 I know is 50, and 5 times 20 I know is 100. So according to this label here, it is safe for my patient to be able to take 50 to 100 milligrams a day. We go back up and look and see what our patient is taking in a full day. Looks like the order dose was a little too high. They're taking 50 milligrams too much. So the answer would just simply be no on this. All I'm going to ask you guys on these questions is just whether or not the dose is safe. So, it'd be different if we had a patient who maybe weighed a little bit more. Let's say, same order dose, same, excuse me, I'm starting to get sick, I think, and I'm a little nasally. Say the dose that's been ordered is the same, and the safe range is the same since it's the same medication. So we've got just a different patient, though. Let's say we have a patient who weighs, let's say 22 pounds. So 22 pounds. So again, to figure out what they weigh in kilograms, we divide that by 2.2. That means we have a patient who weighs 10 kilograms. So for this patient who's a little bit larger, we're going to multiply by both sides of that range to see what's safe for them. And 10 times 10, I know, is 100. So let me get a different pen color here. Excuse me, is 100. 10 times 20, I know, is 200. So that means, according to this label, it is safe for this patient to take 100 to 200 milligrams per day. Well, according to that order dose, again, they're taking 150 milligrams per day, and that falls right in the middle of that safe range, so therefore it is definitely safe for this patient to take that amount. So in this case, the order dose is safe. So keep in mind with that, whenever you're dealing with safe range questions, you're going to take that weight and multiply it by both sides of that safe range so that you can see what specifically is safe for your particular patient, and that, take a look and double check that with the ordered dose and see if it's safe or not. And again, the answer to this would simply be yes or no. All right, guys, I hope that helped, and I hope you guys are ready for today's quiz. And I will see you guys next week. I've got a lecture for you on IVs after this. But again, I'll see you guys next week. Thanks.